there we go, 3x squared here. So when we look at that, it's kind of what we expect to see. I'm going to just change the domain here. So I'm going to go through the menu, I'm going to go window zoom, and I'm going to do the window settings. And I'm going to go from -3 up to 5, just because. Great, that's nice, but you know, you can't quite see what's happening up here. So a nice zoom feature is menu, window zoom, and zoom fit is a good one. Look at the picture, it gives you a clue as to what the zoom feature does. So it just kind of scales up on the y-axis to make the graph sort of fit the full window. So that's great. So now Control T, the magic button, and now you've got your table of values. Look, you've got your input and you've got your output. Okay, so let's have a little look. What do we do with -2? Well, it says x squared. So we square it first, -2 squared, +4. Then we times it by 3. That gives us 12, okay? It's not 3 times -2 first and then square. The squared just belongs to the x. So square these numbers first and then times it by 3. Control T, turn off the table. But now we're interested, of course, in finding the x, y values. So let's see those physically on the graph. Menu, actions, and we'll go coordinates and equations. It's number 8 on the new calculator. I think it's number 6 on the old calculator. So click, and now just put a point on the graph. Oh, okay, so look, I've done it the wrong way around because I'm trying to click a point on the graph to get the coordinates, but there's no point there, right? So let's press escape. Let's do it the other way around. Menu, let's go and analyze the graph, and let's find dy by dx first on the graph, okay? And this point here, can you see? This actually tells us the gradient at that particular point on the graph, the steepness. Now if this is modeling some kind of real life rocket, maybe height above the ground and time, then this would model the actual speed of the rocket at each individual time period, okay? So you can see there's a quadratic, the steepness, the gradient is increasing. Alright, so now let's actually find out what the coordinates of this point are. Menu, action, and again it's the coordinate equations here. Number 6 on the old calculator, I think. Click, and now it allows us to point to something. Click in space. Once you've done that, if you keep clicking, all you're doing is trying to get the coordinate again. On the top left, you've still got this particular coordinates and equations thing on. So press escape, gets rid of it. And now the magic happens, double click, and then type in 2, enter. Beautiful. So this point here has got the coordinates of 2, 12. So when x is 2, the height is 12 according to this, and the gradient also is 12. Coincidence? Well, let's change this. Let's change this to 3. Okay, so the height here is 27 above the ground, but the gradient is 18. And if I change this to 4 now, you see the gradient is 24, but the height is 48. So you can use those numbers to actually analyze what might be happening. You know, to get from this 4 here to this 48, we have a rule here. We square the number, 4 squared is 16, and times by 3, and we get 48. The key thing for you to try now is, well, what do we do to the 4 here to get the 24? Certainly 4 times 6 is 24. But the rule you find has to work for all x numbers. 3 times 6 gives me 18. So that's interesting. Does that work all the time? No matter what x value I have here, I just times it by 6 to get the gradient. So that's for you to find out and play and explore.